Hey guys, so today I'm going to talk about the result of my previous experiment, which is making copper hydroxide. So finally, after all that filtering steps, I add some water to clean it and I added some acetone, and this is the final product dried. This is dried copper hydroxide. You can see here. So since I did it in a small scale, the amount of copper hydroxide being produced was also quite small. These two petri dishes have the same weight. So if I take this top loading balance, I'll on it. And since these petri dishes have the same weight, I'll first put this, and it's about 44 grams. So when I tear it and make it 0 and put this petri dish with the copper hydroxide, it can accurately tell the weight of the copper hydroxide. So it seems that we have 12 grams. Wait, I'll show you it. 12 grams. So in the previous video I couldn't talk much about copper hydroxide. So in this video I'm going to talk about it. Copper hydroxide is the hydroxide of copper with the chemical formula of CuOH2. It is a pale greenish blue or bluish green solid. Some forms of copper hydroxide are sold as stabilized copper hydroxide, although they likely consist of a mixture of copper carbonate and hydroxide. Copper hydroxide is a weak base. Copper hydroxide has been known since copper smelting began in around 5000 BC. Although the alchemists were probably the first to manufacture it by mixing solutions of lye, which is sodium or potassium hydroxide, with copper sulfate. It was produced on an industrial large scale during the 17th and 18th centuries for use in pigments such as blue lter and Bremen green. These pigments were used in ceramics and paintings. So from laboratory synthesis, copper hydroxide can be produced by adding sodium hydroxide to a dilute solution of copper sulfate. But I did it by adding ammonium hydroxide to copper sulfate solution, then adding sodium hydroxide to give the precipitate of copper hydroxide. So there are couple of ways to make this copper hydroxide. So just like in this reaction, by adding sodium hydroxide to copper sulfate solution, the precipitate produced in this manner. However, often water contains an appreciable amount of sodium hydroxide impurity. A pure product can be attained if ammonium chloride is added to the solution beforehand. Alternatively, copper hydroxide is readily made by electrolysis of water containing a little electrolyte such as sodium sulfate or magnesium sulfate. A copper anode is used, often made from copper scrap. So when talking about reactions of copper hydroxide is stable to about 100 degrees Celsius. It decomposes at higher temperatures into copper oxide and water. Copper hydroxide reacts with a solution of ammonia to form deep blue solution of tetraamine copper or CuNH3,4. It's a complex ion. It catalyzes the oxidation of ammonia solutions in presence of dioxygen, giving rise to copper amine nitrates. Copper hydroxide is mildly amphoteric. It dissolves slightly in concentrated alkali, forming CuOH4. It's also a useful reagent for organic chemistry as well. Copper hydroxide has rather specialized role in organic synthesis. Often when it's utilized for this purpose, it is prepared in situ by mixing a soluble copper salt and potassium hydroxide. It is sometimes used in the synthesis of aerial amines. For example, copper hydroxide catalyzes the reaction of ethylene diamine with 1 bromoanthraquinone or 1 amino 4 bromoanthraquinone to form 1 2 aminoethyl aminoanthraquinone. These chemical names are really hard to pronounce. Or 1 amino 4 2 aminoethyl aminoanthraquinone respectively. Copper hydroxide also converts acid hydroxides to carboxylic acids at room temperature. This conversion is useful in the synthesis of carboxylic acids in the presence of other fragile function groups. The yields are generally excellent, as is the case with the production of benzoic acid and octanoic acid. So some uses of copper hydroxide are: copper hydroxide in ammonia solution, known as the Schweizer's reagent, possesses the interesting ability to dissolve cellulose. This property of it led to it to being used as the production of rayon of cellulose fiber. It is also used widely in the aquarium industry for its ability to destroy external parasites in fish, including flukes, marine itch, brook, and marine velvet, without killing the fish. Although other water-soluble copper compounds can be effective in this role, they generally result in high fish mortality. Other copper hydroxides include several copper containing minerals, including contain hydroxide. Notable examples include copper carbonate which has copper hydroxide in it, formerly known as basic copper carbonate, and so many other compounds of copper hydroxide. So as I said before, when reacting copper hydroxide with the ammonia solution, it can produce the Schweizer's reagent which can dissolve cellulose. So I felt interesting about this experiment, so I'll probably do it in the next video. So now I'm going to transfer this copper hydroxide to this bottle over here. So let me just do it now. You can see the light blue copper hydroxide solid dried. So as soon as possible I'll do the video on dissolving cellulose with this ammonia and copper hydroxide complex. So please subscribe to my channel and like and comment as you wish. Stay tuned for the next video soon.